Hi, welcome back, and to this, our section on relational database theory. Before we can jump on the keyboard and start writing code, we've got to design a database. And to do that means we need to all be sharing some common terminology, the essence of this particular lecture. We also all need to know how to normalize a database, that is, set it up properly such that SQL works. And that'll be the topic for our next two lectures. And then we'll end this section by taking a look at entity relationship diagramming. That is the method by which one documents a database design. Cool enough. Let's jump in a deep end of the pond and start learning some relational database terminology. All right, our first term, RDBMS, Relational Database Management System. That collection of software which allows us to implement a relational database. Guys, these things are old as dirt. They precede me, and that's saying something. Relational database management systems were really conceptualized by a Dr. E.F. Codd way back in 1970 when he was working at IBM. A couple years later, they came out with their first product, and by, I think it was like 1974, Oracle had a production version as well. Yeah, strangely enough, I was also around shortly thereafter. I wrote the first cost-based optimizer for RDB, Digital Equipment Corporation's initial entry into the RDBMS market. RDB was subsequently purchased by Oracle, and immediately thereafter in 1984, Oracle got a cost-based optimizer as well. So 1 point for Rick on bringing the cost-based optimizer strategy into this particular area of technology. Yeah, just as an FYI, the optimizer is part of the RDBMS kernel, which determines the best way to realize a query. That is the least costly method by which to complete a query as given to you by a piece of SQL. Cool. My role in this whole thing. Okay, let's move on to our next term then, schema. Schema is that set of objects used to realize all or part of a business enterprise via relational model. Seems straightforward enough, right? Well, in fact, any single RDBMS can support multiple schemas. Here we have an example of one that's supporting an HR, an accounting, and distribution. It's very common. What's the bad news with respect to schema? People who actually do this for a living never refer to these things as schemas. They're always the database running on Oracle, or they're the DB. Nobody calls them schemas. Me, throughout this course, I'm going to try to stick with the proper usage, and so I will try to use schema. What's the likelihood? I'm going to forget a couple times and call them a DB because, hey, I've been doing it for 25 years, and that's what I've been calling them. I apologize now. Please know that when you're taking that Oracle test, the proper term is schema. Alrighty, our next term, entity. An entity, quite simply, is a something. It's a something about which we are going to store information within our schema. Customer, order, product, it's a something. Next term, relationship. That is, how are two or more entities associated? Typically, relationships are described via their degree, a one-to-one. That is, for every one of these entities, there's exactly one of these entities. A one-to-many, customer to orders. A single customer can have multiple orders. You get the idea. All right, moving along. We're doing well here. Our next term is a table. A table is the physical method via which an entity is realized within a schema. It's the bucket we're going to store that information into. They're known as tables. Tables have columns, which represent the various attributes of that entity. Customer, for example, first name, last name, email, telephone, you get the idea. Each table also has rows. That is the method by which we store each instance of an entity. Here we're looking at 8 or 10 rows of data within the customer table. Each one representing a single customer out there in the universe. Real straightforward stuff. So thing to remember is schema is made up of tables, which represent the entities, and columns, the attributes, rows, the instances of each of those entities. Good enough. All right, next term, we're whooshing through this stuff because I know it's not terribly exciting. We want to get onto that keyboard and start doing the good stuff. But our next term is primary key. That subset of attributes or columns within a table which uniquely identify each row. Maybe it's email. Email is usually unique across each customer, so we could say email is the primary key of the customers table. In actuality, primary keys are almost always integers, ascending, sequential integers. Why? Because they don't take up much space, and that helps us with respect to high-speed performance of our database. But again, we'll get into a lot more on that later on. Next term, foreign key. A foreign key is that set of attributes within one table which is the primary key of a second table. It's the method by which these relationships are realized. For example, we might have primary key of the customers table be customer ID. We then might have it serve as a foreign key into the customer address table, wherein we have many addresses for each customer. We then create the primary key of the customer address table as customer ID and address ID. Foreign key is the customer ID, and that's the way we constrain the relationship. We'll get into it more, but just for now, please understand that primary keys and foreign keys, when we're doing our normalization in the next couple of lectures, it's going to be the entire basis upon which we're going to design our schema. And we're going to do that to ensure that SQL works properly. You design these databases wrong, there I did it. You design these schemas wrong, and SQL, in fact, can give you anomalous information. So be careful on it. We're going to learn to do it the right way, and hopefully you'll follow that going forward. Okay, gang, short and sweet on the terminology because I don't want to beat us up with this. I just want to ensure that we're all speaking the same, using the same vocabulary going forward. What do we learn in summary? RDBMS, Relational Database Management System. That set of software which is used to realize a relational database model. Been around forever practically. And the good news is the reason they're staying around is because they're incredibly easy to use. That makes them a perfect solution. Schema. That set of objects used to realize a part or all of a business entity within an RDBMS. You can have multiple schemas within a single RDBMS. Bad news, remember we spoke about it, they're commonly called DBs running on Oracle. It's the more standard vocabulary, but we're going to try to use the proper vocabulary in this course. Next, open that schema up and start looking inside. We have tables, which are the physical manifestation of our entities. Tables are made up of columns, which are the attributes describing each entity, and rows, which are the instances of each entity. Each table also has a primary key, that is that subset of attributes which uniquely identify each row. And tables also commonly have foreign keys. That is a subset of attributes in a first table that represent the primary key of a second table, thus realizing a relationship between those two tables. Remember our customer address example, and you'll do fine. Okay, that concludes our terminology section, our lecture rather. I told you I don't want to beat a horse. I want to get to the good stuff where we're touching a keyboard. So we're going to go through this stuff relatively quickly. Please understand, if you are taking this course as part of a prep for a certification exam, this terminology stuff is hugely important. It's where these guys live. So please make sure you put it to memory. All right. Looking forward to seeing you in the next lecture, where we're going to start learning about normalization, the process by which we properly design our tables to ensure SQL works properly once we start moving around with it. I had some fun. You go out there, have some fun, but keep on learning.